and welcome to ACR Journals on Air podcast. I am your host, Vicky Shanmugam. Today's topic is a disease first described by the ancient Egyptians and known as the disease of kings. Hippocrates referred to it as the unwalkable disease, and the famous English physician Thomas Sydenham was disabled by it. But it's also the disease of the common person, affecting 4% of the US population, with some pockets of prevalence even higher worldwide. I am, of course, referring to gout. And the manuscript we will discuss today is Association of Gout Polygenic Risk Score with Age at Disease Onset and Tophaceous Disease in European and Polynesian Men with Gout. It was recently published in Arthritis and Rheumatology, and a link to the manuscript and its supplementary materials and disclosures are in our show notes from today. I'm excited to be joined by the manuscript's senior author, Dr. Tony Merriman. Professor Merriman is an internationally renowned scientist and leader in the genetic basis of gout and rheumatoid arthritis. He received his PhD in biochemistry, specifically studying bacteriogenetics, at the University of Otago in New Zealand. He then completed 4 years of postdoctoral training in genetics at the University of Oxford, where he studied the genetics of type 1 diabetes. He subsequently returned to New Zealand, where he studied the genetics of RA and gout. And in 2020, he moved to Alabama to join the Division of Clinical Immunology and Rheumatology at the University of Alabama at Birmingham, where he is currently Professor of Medicine and the Lou Bridges Endowed Scholar at the University of Alabama at Birmingham. His current research interest focuses on the causes of gout and translation of genetic findings into better health outcomes for people with gout. Welcome to the show, Tony.
Thank you, Vicky. It's great to be here.
So, Tony, we know from epidemiology that the development of gout is multifactorial, involving complex interactions of genetics with diet, lifestyle exposures, and medication use. And there have been several previous genome-wide association studies on gout. I wondered if you could tell us about them and set the stage for why you conducted this current study.
Yes, the previous genome-wide association studies in gout have been published over the past 10 years or so, and I think it's fair to say that when you compare the genome-wide association studies in gout with association studies, say, in rheumatoid arthritis, for example, they've been relatively small, and that's an issue in the genetics of gout. But when you get a genome-wide association study, you get a lot of individual genes that associate with gout or whatever disease you're looking at. And that's actually very informative. It tells you about the mechanism of disease and can identify new drug targets. However, what can be done with genome-wide studies, the data from that, is that you can combine the individual genetic effects into a sort of a summary genetic effect and start looking at this summary genetic effect has greater power, and then start studying and applying that to predicting or evaluating outcomes in gout, for example.
And I guess that brings me to my next question. I hope you'll excuse the pun, but genetics, like humans, is constantly evolving. In this study, you developed this thing called a polygenic risk score. Can you bring us up to speed on what that is?
Yes, so I sort of alluded to it in my previous answer, but in previous studies of individual genetic effects on outcomes in gout, for example, answering the question, is genetics important in age of onset of gout? We've generally studied the individual genes and individual loci, and with a polygenic risk score, for example, let's just pluck a figure out of thin air, we might have 24 different genetic effects from a GWAS. Rather than studying 24 individual genetic effects to study them individually against the outcome, say age of onset or development of tophaceous gout, we will combine them into one single score. So to explain what that is that, at any particular gene that confers risk to gout, there will be a specific allele that increases your risk. And everyone either has 0, 1, or 2 copies of an allele or genetic variant that increases your risk. So we simply count up the number of alleles across the, say, 24 loci to get a genetic risk score.
And you have a lot of information in the supplemental materials about the specific characteristics of the UK cohort in your study. And I think that was essentially your discovery cohort. Could you summarize some of the critical features of that cohort for the audience?
Yes, so it was a discovery cohort. That was a cohort that we did our own genome-wide association study in gout in roughly 7,000 cases and 350 odd thousand controls from the UK. So that's where we discovered the genes to enable us to construct the polygenic risk score. Now, the UK Biobank was begun in 2006, and it really has been an extraordinary resource for people studying genetics of disease. And they've collected quite a wide range of information, not only genetics, but also lifestyle, diet, and a huge amount of information on outcomes and disease. It's linked into GP records, and the data set is just getting better and better. So overall, it's got about roughly 500,000 individuals from the UK, spread all through the UK, who are deliberately recruited to be between the ages of 40 to 70 years of age. So again, that is a limitation that we have to acknowledge for findings from the UK Biobank. It is only relevant for that age group. And the other important point about it is that it is primarily of white European origin, very primarily. So again, the findings from that can only largely be generalized to the European population. That's the cohort that we developed the polygenic risk score from, so it had cases and controls. But I would point out that the rest of the study, the majority of the study, was carried out in gout-only cohorts that had more granular information about gout. So in the UK Biobank, we ascertained gout by self-report and use of urate lowering therapy, typically allopurinol. That's about the extent of the information on gout. We don't know, for example, what the age of onset is, and there's certainly no deeper clinical information on tophaceous disease. So we use that as discovery and then move to gout-only cohorts with better depth of phenotyping on gout per se.
Yeah, no, that makes sense. And so you generated this kind of combined polygenic risk score from that original UK cohort. I saw that you generated actually two risk scores, one for gout and one for serum urate. And I am a simple clinician, so my instinct was that those should overlap. Could you explain the rationale for looking at both, and did they overlap?
Okay, they do substantially overlap. And we all know that serum urate hyperuricemia is a biggest single determinant of gout. It's essentially essential to have hyperuricemia. And we also know from gout GWAS that the strongest genetic effects on gout are those encoded with urate transporters. So these are transporters that will regulate urate levels or contribute to regulation of urate levels through their effects in the kidney, where urate is filtered out into the urine and taken back up, filtered out and taken back up, a complex regulation of urate filtration and uptake, and also in the gut transporters. So these well established as having the strongest effects in gout, and transporters such as, and one we specifically refer to a lot in the paper, is one called ABCG2, which is a export transporter, and it pumps urate out mostly in the gut. So there is substantial overlap, but there are still differences. There were one or two loci that in our gout GWAS that we didn't see in the urate GWAS, which suggests that they are involved in the inflammatory process of gout.
Interesting.
And so that distinguishes the gout from the urate. But really, we did, to be the blunt and simple answer about doing the urate score was a reviewer asked us, and we thought, well, that's a good idea. We hadn't originally done that in the submitted paper, and we did find that, in jumping forward a little bit, but not letting all of the cat out of the bag, that the polygenic risk score in gout that we developed from gout, as opposed to one that we developed from a completely independent genome-wide association study in urate, the gout one performed better for gout than the urate one, but not a huge amount more so.
Yeah, interesting. So was it reviewer 2, or you're not willing to say?
I actually can't remember. But, it was a very valid comment they made.
Yeah.
And, we always try to respond well to reviewers when we're revising papers, because it's a really important part of improving your work.
Yeah, and sometimes that feedback is something really important that you hadn't thought of. So it's actually nice, and I think kind of validating for both parties to hear that it did.
Yeah, you often get some real nuggets.
Yeah. So let's move now to the main part of your study, because that was really unique, because there you looked at several different cohorts, obviously enriched now for patients with definite gout, to look at the correlation between the polygenic risk score and gout severity. And you measured that by the presence of tophi and I think age at gout onset. And you included several cohorts from Australia and New Zealand, and some with a more predominantly European ancestry, and then several unique Polynesian cohorts. I wonder whether you could tell our listeners a little bit about those specific cohorts, what made you pick each of them, and what different characteristics each cohort brought to the study.
Yes. So starting with European cohorts, it's largely a reason of availability, really. And one slightly unfortunate aspect of genetics of gout and any other complex condition is that it really is dominated by cohorts of European ancestry or folks of European ancestry. And that has allowed us to develop very large studies, but focusing on European, which creates an issue of inequity of participation of other ancestral or ethnic groups in genetic studies. So we use European because of cohorts like the UK Biobank that are readily available. The cohorts included that we used European-dominated cohorts from clinical trials and cohorts that we collected by collaboration in Australia and Europe over the years. But in New Zealand, the Polynesian folks in New Zealand, and I will explain what I mean by the term Polynesian. So Polynesia is the Greek for many islands, and it encompasses islands from the Western Pacific, Samoa and Tonga, all the way up to the North Pacific, and that's Hawaii, and all the way out to Eastern Pacific, which is Europe, Easter Island, and also Aotearoa, New Zealand, down in the south. In New Zealand, the population the Polynesian population is comprised of two populations, really. One is the indigenous Maori, who arrived in New Zealand roughly 850 years ago, sailing from the Cook Islands, which is sort of up to the north and the east of New Zealand. And more recently, Pacific Island people have migrated to New Zealand and known as a group called Pacifica or Pacific Island people. And the nations, the predominant Pacific Island nations and people who are now living in New Zealand and the New Zealand citizens are Samoa, Tonga, and also the Cook Islands as well. So I have spent the majority of my career thus far in New Zealand, and working in gout, we do have a focus on working with Maori and Pacific populations. One of the reasons for that is that gout is really very, very common and severe disease in Maori and Pacific populations. The age of onset is earlier compared to European folks living in New Zealand, at least 10 years earlier. And the prevalence is 2 to 3-fold more, and the disease severity is increased. And collectively, that has a large impact on communities. And we were recruiting these cohorts for this study from Maori and Pacific. You travel to communities and constantly you hear about the impact of gout in those communities. So we included the Polynesian cohort in this to increase the equity of participation, but also we were very interested in seeing how a polygenic risk score developed in a European population worked in a different population, in this case, the Polynesian population of New Zealand.
Yeah, no, and I think incredibly valuable. So tell us what you found. Did the polygenic risk score that you developed from the European cohort predict severity of gout in these other ancestries, or did you find something unexpected?
We kind of did find something slightly unexpected, but that'll come in time. But we now routinely look at men and women separately in gout, and I think we will come to this shortly. So we looked at men separately from women, and we looked at European men. So these are the gout-only cohorts, European men, and we looked at Western Polynesian men. So I should also point out that Western Polynesia, folks from Samoa and Tonga largely, and Eastern Polynesia are folks from New Zealand Maori and Cook Island Maori, and we would also include Hawaiian and Eastern Polynesian. And there are real genetic differences between those two broad classifications. So that's why we now analyse them separately. So we looked at European men, and we found that the genetic risk score, every unit increase in that genetic risk score decreased the age of onset by 3.6 years.
Quite a long time.
Yeah, exactly. It's in Eastern Polynesian men, it was 6.4 years, so it's even stronger. And in Western Polynesian men, it was roughly equivalent to European men, 3.5 years, but we found no association in women. One of the other reasons we did this study is that we already have evidence in the literature that genetic effects associate with age of onset in gout, and certainly the ABCG2 gene that I mentioned earlier has individually been associated with onset of gout, and it's a very strong genetic effect in gout, and we know that it exports urate into the gut or out of the body, but we have a strong suspicion that it's also involved in the inflammatory process of gout. And I think as a sort of aside and a watch this space, we're going to see as larger gout GWAS, genome-wide association studies are done, we're going to see genes or genetic effects that both have an effect on urate and have an effect on the inflammatory process of gout. And ABCG2 is likely one like that. We're not sure how, the mechanism, but it may well turn out to be the case. But anyway, we also removed ABCG2 from the genetic risk score, but we've found that this polygenic risk score, I use polygenic and genetic risk score sort of interchangeably here, they're the same thing, that it's still associated with earlier age of onset, even without ABCG2 in there. So now we've extended it from, knowing that it's just not all about ABCG2, but that your collective genetic effect does, in men, and that's important, associate with earlier onset of gout. We also looked at tophaceous gout, and that's more challenging to look at because, while you can phenotype and get information on tophaceous gout, of course, it's really will be very dependent on how long you've had gout. So when we did those analyses associating the polygenic risk score with tophaceous gout, we also had to take account of amount of years people had gout, and we adjusted for that. And in that analysis, we only found association in Eastern Polynesian men, increasing the risk, the genetic risk score, increased the risk of tophi by about 50%, but only in Eastern Polynesian men, statistically significant.
Is there a difference then in the tophaceous burden in the two Polynesian groups, or do they have a similar risk?
That's a hard question to nail, and I don't think we can draw any strong inferences from our data because of the way the cohorts were differentially collected. We had cohorts from clinical trials conducted throughout the world, and also for example, in the Australian, New Zealand, European and Polynesian cohorts, we were also oversampling for type 2 diabetes and disease as well. So I don't want to make any inferences about was tophaceous disease more prevalent in our cohorts. I suspect not. In fact, if you look at the data, it probably wasn't. But if you're taking a genuine population-based approach, you will find that gout, and there's literature out there that tophaceous gout is more prevalent in Polynesian people and more severe, more hospitalization, etc.
And I guess so. Follow up to your earlier point about there being some differences between the risk score for gout and the risk for serum urate. Can you fill us in on what you found there?
Yes, we found that the gout risk score was more strongly associated with age of onset, but not by a whole lot, really. And I think that's telling us that these findings certainly need extended and larger cohorts in the future. And it's suggesting that, certainly the urate component of gout does associate with earlier age of onset, but we're going to see the inflammatory or component on top of that amplifying the genetic effect and even earlier age of onset. So they performed similarly, but the gout one did generally perform a little bit better.
Yeah. Okay.
Consistently better, but not statistically significantly better. The 95% confidence intervals all overlapped.
Interesting, which I guess is kind of inherently what you would expect to some large extent.
So we were, reassured by those findings.
Right. And I'm sure your reviewers were too.
Yeah. And I think, clinicians will have expected that.
Yeah,
as you sort of said before.
Okay, so I have to bring you back to something that I cannot fail to address in this manuscript. So you comment both in the title and in the text of the manuscript that you did not detect these associations in women. I cannot let that go undiscussed. So I'm wondering if you would be willing to speculate on why that is.
I certainly am, because that's becoming increasingly a research focus of us here. One of the issues that we always find to begin with in studies in gout is that because gout is more prevalent in men, about 3 to 4-fold more men have gout than women, then, women are underrepresented in studies like this. That's number one. So it could be a power issue. But if you look at the numbers in there, and if you look, for example, at the association of the genetic risk score with age of onset in women, it's virtually zero, way close to zero. So it's not even remotely like what it is in men. We do have to acknowledge that power is an issue. But we think that the reason is different, in that we know that women get gout at least 10 years on average older than men. And if you look in the data, that's evident throughout all of the cohorts, at least 10 years later. And we know that it tends to come on in women around about menopause as urate levels come up. And that's often been ascribed, and I'm sure this is a factor, to the role of estrogen pre-menopause, and we know that women have lower rates of hyperuricemia and naturally lower urate levels pre-menopause. So what the findings, I think we can be quite confident in saying, is that the genetic effect in age of onset is kind of restricted to men. But what we actually think is happening here is that there are different drivers of gout in women, and we can conclude from the male findings in that genetics is a relatively strong driver of gout. Genetic variants and urate transporters playing a role in raising urate levels in men earlier in life than women. But one thing, and you get a hint of this if people would take a look at the UK Biobank findings in our supplemental table 3, and if you compare the rates of comorbidities of gout, cardiometabolic comorbidities such as type 2 diabetes, heart disease, kidney disease, dyslipidemia, you'll find, and you do a rough sort of ratio calculation in men and women compared to non-gout men and women, you'll see that these comorbidities are considerably higher in women with gout when you compare to women without gout, as opposed to the similar comparisons in men. And we are following up on this, and we think that in women at a later onset of age will develop these comorbidities, and we think that that's more of a driver of gout than genetics per se, as it is in men. And for example, in women, kidney disease is the strongest effect that if you just take a look at those numbers, and we certainly know that declining kidney function increases urate levels, and that's well established. So it may be kidney disease is driving gout more in women, and we know that insulin resistance also drives up urate levels as well with type 2 diabetes. So we're working in hypothesis that in women, the development of comorbidities, cardiometabolic disease is a considerable driver of gout.
Yeah, I was kind of wondering also, the discovery cohort from the UK that you used kind of cuts off the age limit, I think, at 70.
70,
Is it just that you're not following the women long enough for them to develop clinically manifested gout?
Yeah, I think that could be an issue in that we don't have as great a range of women in age of onset. They're all, in their 60s and 70s probably, mostly when they get gout, and that will be an issue. But we can, with the UK Biobank, is sort of turning into a prospective longitudinal cohort, that we can now go back and ascertain gout in women who are, say a hypothetical woman who was recruited in 2006 at the age of 60, for example, and then
Yeah.
So with the way they are now linking into GP records, and so that will be a question that can actually be answered.
Great. So that will be a kind of gold mine for you, I would imagine,
Yes,
as a geneticist then.
Take the opportunity to acknowledge the first author here, Nick Sumpter. He's just graduated with his PhD, and he's a superb talent and did some superb work here. But he is carrying on, and he has a really strong interest in trying to understand the differences in gout etiology and drivers between men and women. And also, just as an aside, if you like, we are now using the American All of Us cohort, which means we can extend these findings and start looking in the African American population in particular. And it is looking like findings in Europeans are not necessarily transferable across to, let's say, the US African American population, for example. So I think we just need to emphasize that studies in one population just aren't necessarily transferable over to others, and we have to be very careful about concluding that could be the case. That's why I'm very pleased that we could see, at least in the Polynesian group, that the findings are largely similar.
I thought you had a super interesting kind of way of building these different cohorts and drawing all those different components in. And we will probably get back to that a little bit later in the discussion. In your manuscript, in the discussion of your manuscript, you talk about one of the limitations of your study design being something called index event or collider bias. I wondered, could you tell us what collider bias is? And do you have any tips for other people designing studies, particularly genetic studies such as this one, on addressing or avoiding it?
Yes, that is the toughest question you could possibly ask, because it's possible to explain what it is, but to give you the whys and wherefores, I think requires a hardcore degree in epidemiology. So let me explain what it is and the tips for how you can address it. So in this context, our incident disease, or the disease we are looking at, is gout. And collider bias occurs when, and I'll explain what the collider is shortly, occurs when risk factors for the incident disease, so gout in this case, and the risk factor is the genetic polygenic risk score, are used in studies of progression and severity in observational studies like this. I would emphasize that in our situation, this collider bias phenomenon will apply to tophaceous, the testing for association with tophaceous gout, because that's sort of progression of gout, but not the age of onset, which is a measure of onset, incident gout. So age of onset findings are not subject to this collider bias. So it occurs if the risk factor in the genetics, I emphasize that this is a genetic score, polygenetic score, causes disease incidence, but not progression and severity. So if let's say there was the polygenic risk score played no relationship in tophaceous disease, then we would observe that actually the polygenic risk score would protect from tophaceous gout. That would be the observation and the implication of collider bias. And I'll sort of explain a little bit more about that in a minute. And the other side of the coin is if the measured risk factor here does actually also play a role in tophaceous disease, then we will get an effect size that is closer to the null, so it suppresses the effect size. What's happening is that the measured risk factor here, so this is again the polygenic risk score, is colliding on the incident cases, so that's gout, so it's colliding on gout with unmeasured factors. And of course, in an epidemiological study, you get lots of unmeasured risk factors. And that's the classic example of it is obesity and cardiovascular disease. We know obesity is causal of cardiovascular disease, but if you start asking the question, how does obesity or BMI relate to outcomes in cardiovascular disease, then it looks protective, which is completely counterintuitive and explained by this phenomenon of collider bias. And again, that's what it is.
So what do you do about it?
It's meant to explain why, because it really is a complex phenomenon to get your head around, but it can be mitigated. So what you can do, and we didn't do it in this case for a couple of reasons, but you can actually take population-based controls. So for the tophaceous disease, we could have split our gout cohort into people with and without tophaceous disease, and then used population-based controls. So in other words, people without gout, and tested for association. And we would expect to see stronger association of the polygenic risk score in tophus positive gout when you compare tophus positive gout with people without gout compared to the tophus negative gout comparing to people without gout. However, we run into power issues there because we're dividing the cohort up. And again, the other issue we run into doing that in this particular case is accounting for length of disease onset, how long people have had disease in the tophaceous positive gout. As we know, that's an important factor. So we ended up not doing that, and we have to acknowledge collider bias. But what it would have done is we would have ended up with underestimates of the effect size on tophaceous disease. And I think, and to extend these findings, it emphasises that we really do need larger and better phenotype cohorts of people with gout, which is not the case at the moment. So we can take a better job at investigating the association of the polygenic risk score with gout and investigate the impact of this collider bias. In other epidemiological research, we have successfully accounted for it in, looking at gout and COVID by using population-based controls. That was more straightforward to do that in that particular case. But here it's challenging.
Yes, but more for the future, I guess, as you're kind of designing for the future. I'm going to change direction now a little bit, Tony, and I want to talk a bit about your journey, both around the world, through life, through the field of genetics. And I'm going to start with your time at Oxford. I think we actually probably overlapped while we were there, so it's possible we passed each other cycling through Jericho or walking through Pulp Meadow on a summer evening, although I suspect you probably spent your time much more wisely than I did. I'm wondering if you could reflect a little bit. It's been almost 30 years since you started your postdoc, and while the buildings at Oxford have not changed much in that time, the field of genetics has evolved quite a bit. You spend your career predicting how someone's genes might impact their life. Did you ever contemplate back then how rapidly the field of genetics would evolve during your career?
No, not at all. And I'll extend that by just saying that we went to postdoc, me and my wife, before we had children. I switched from genetics of bacteria to genetics of type 1 diabetes, and I was very interested in type 1 diabetes in particular because my wife got type 1 diabetes as a 15-month-old baby, so I was very interested in the genetics, but also environment as well, the interplay of the two. So I went to train there, but we had a wonderful 4 and a bit years in Oxford. We had some lifelong friends, and we really enjoyed living in the UK. But coming to your actual question, the genetics has just changed so much. Back then, it was about 10 years before the first human genome had been sequenced, and we were struggling to find genetic markers. So genetic markers or genetic variation is critical in studying the genetics of complex disease. And back then, I recall we used genetic variants called microsatellites, which required a lot of work. So they are essentially dinucleotide repeats that vary between people and very difficult to genotype. And I spent many hours, countless hours, genotyping these microsatellites. And we were generating our own data. And one big difference now is that we would never do that now. We outsource all of our genetics, and now it's becoming more and more affordable to get whole genome sequenced, and you do that once for an individual and you've got all of that inherited genetic information there forever, so to speak. So we outsourced that. We didn't have any idea about how genetically diverse human beings were or how many genetic variations there are in the human genome. Just an incredible number, tens of millions, hundreds of millions. We had no idea then. We had no idea that genetics would be so complex. So height, the genetics of height, for example, is probably the first polygenic phenotype that's been, or the most characterized one. And we know there are literally thousands of genetic variants that have an effect on height with different effect sizes, of course. So we didn't have any idea of that. We also really didn't have any idea about the epigenome, how important that is, where you have modifications of the genome that influence how genes are expressed, so reversible modifications. So that was another thing. But the thing that's really, really I find so incredible is just how highly organized the nucleus, the way DNA packed into the nucleus and how incredibly organized, and this is a result of hundreds of millions of years of animal evolution, how cell types open up different bits of DNA at different times and how incredibly organized that is. And that's now where we're primarily studying genetic effects, how the inherited genetic variants that we know play a risk in gout, how they influence gene expression largely. So that to me, that's the biggest thing, the incredible and beautiful complexity of how the human genome and any other genome is organized and controls gene expression at different points and different times from conception all the way through development.
It is incredible, really, how much this field has exploded. After your time at Oxford, you moved then back to New Zealand, but jumped from studying diabetes to studying rheumatoid arthritis and then onto gout. What was the impetus for that change in direction? Was there some kind of external force, or was it all in your genes all along?
It was an external force. I went back in 1998, and one of the interesting things about genetics of autoimmune disease is that the same genetic variant can confer risk to different autoimmune diseases. So I was studying a locus that conferred risk not only to type 1 diabetes, but also rheumatoid arthritis. And so I went back and I thought I planned to recruit and study both patients and their families in type 1 diabetes and also in rheumatoid arthritis. And what I found was that the rheumatologists were by far and away the most collaborative and supportive network in New Zealand than the pediatric endocrinologists. So it just went a lot better, and I enjoyed, working with those people. And then to go from rheumatoid arthritis to gout, that was an incredible external force by the name of Professor Nicola Delbeth, who was
yes, the great in rheumatology.
Yeah, so she's a long-time friend and colleague of mine. And she returned to New Zealand. So she's based at the University of Auckland and preeminent clinical researcher in gout. And she came back to New Zealand about 3 or 4 years after me. And in fact, she was also in Oxford doing her research component of her training. And she would come to conferences and just say, "Tony, you've got to do gout. Tony, you've got to do gout. Tony, you've got to do gout." So I caved eventually and then moved into gout. And certainly that it was back then, there was no one doing genetics of gout, quite literally, certainly in European population. So it was a wide open field as compared to rheumatoid arthritis. So, and Nicola and other people in New Zealand, for example, Professor Lisa Stamp, have also been hugely supportive of recruitment in these studies over the years. And we've co-authored many, many, many papers together.
Yeah, so that's a great story because kind of gets to the heart of rheumatologists just generally being good, nice people to collaborate with. I love it. So one of the other features of your career is your experience collaborating with and serving some of the unique communities in New Zealand, including the Maori and the Pacifica health groups. Can you tell us how those relationships began and how have you been able to nurture and sustain them over so many years?
So the relationships, you can't plan for them, and it's about connections and maintaining connections. And the first relationship, there is a story behind it, that when I was sort of finishing up on type 1 diabetes, my PhD student was a woman called Jade Hollis Moffat, and she's Maori, and she came from an iwi or a tribe up on the northeast coast of New Zealand, from the Tairāwhiti or East Coast region called Ngāti Porou. And when she finished her PhD, she wanted to switch from diabetes into gout because we were doing more and more gout back then. That was sort of mid-2000s. And we got a connection, and I always remember connecting up with the man there through the chief physician up at this iwi. They had their own health provider called Ngāti Porou Hauora, where Hauora stands for health, and a guy called Dr. Paratini Ngata, and unfortunately he's dead now. He passed away a few years ago, but I always remember talking to him, and then he cut to the chase and said, "Tony, come up here and meet some people and let's get something going." And it's been going since 2006 with Ngāti Porou Hauora. And the key thing is relationships, and personally travelling up there many, many times and getting to know the folks in the Hauora and in the community, and you build up trust and over the years, and that is critical for maintaining those relationships. And it's also secondary factor is health provider having a infrastructure that can interact with, the University of Otago infrastructure that we had in terms of research. So that is important, but relationships are the critical thing, and getting out into the community and hearing what, the grandmas, the nanas from the community have to say, and lodging that in your head and making sure that you do good by them.
Yeah, definitely. For building trust. And I think that's true kind of in many different regions of the world as we're trying to kind of understand some of these genetic issues, really bringing groups in.
Exactly. And a corollary of that is the incredible amount of extra time that is required to build the trust and, recruit people, and compared to if you're doing that with the white European population, very time consuming, very enjoyable, but a huge investment in time.
Yeah, I completely agree. So I'm going to fast forward now to the COVID-19 era. So in October of 2020, when many physicians in America were actually trying to figure out whether it would be possible to move their families to New Zealand, you decided to do the complete opposite and move to Alabama. What was that like? Are you someone who just likes to zig when other people zag, or what prompted that move?
Well, I've been asked that question many, many times. I do like to zig when other people zag. I think that's part of my nature, but it wasn't the case here. That we came, myself and our wife and two younger children, came here for 6 months in 2019, pre-COVID, for a sabbatical. So we enjoyed it. And during the sabbatical here, one of my major grants in New Zealand got turned down. And unfortunately in New Zealand, the government funding of biomedical science is very, very poor at the moment. And a back of the envelope calculation is per capita tenfold less money for biomedical research than there is from the NIH here in the US. So being here then, I ended up having an offer put in front of me because I made the decision, okay, it's getting more and more unsustainable to do this sort of research in New Zealand. Not only the funding, but we lived in Dunedin, and clinically there wasn't the environment for gout compared to the division here, clinical immunology and rheumatology, which is now was headed by Dr. Lou Bridges, now headed by Dr. Ken Sagg. It's a very good environment to be doing translational research in gout, particularly the inflammatory component of it. I eventually got an offer and shifted over here. And one other factor is the tyranny of distance. New Zealand really was a long way away, and important for me is relationships with people both in New Zealand but also international collaborators, and the huge amount of travel I was doing. In 2018, I calculated I spent 2.5 weeks actually sitting inside an airplane, not
Wow.
travel, but sitting inside an airplane, and that's just crazy. So that other major factor. And we enjoyed living here in 2019, so we came back. So the offer was made and signed before January 2020 when COVID hit. So we'd sort of made our and we'd made our bed, so we had to lie in it. So I came over first, eventually in October, which was a lot later than we had originally planned, just with my youngest son, because my wife didn't want to come over here before she was vaccinated. Came with my youngest son, and a big factor in actually coming then in October 2020 was that he did not do well in lockdown with his schooling, and our city schools, Homewood City schools, were opening up then, and I thought if there's any more lockdowns in New Zealand, and the chance that there were here would be better in his schooling here. So it was kind of weird coming over here in the middle of COVID.
Yeah, I bet it was.
But, that's the way things happen, and we really enjoy living here now that we're all back together. Hopefully that answers your question.
Yes, no, it's great. And I feel like the adaptations that so many people made during this time of COVID, we have kind of changed how we make decisions, right? And sometimes your kids' schools really, really matter in a way that you would have not focused on so much in the past. I'm wondering, as you kind of reflect on your career journey, do you have any tips for other scientists who are kind of earlier in their career? Can you give advice on how careers evolve? Any things that you wish you had known at the beginning that you'd like to share?
The first thing I absolutely have to acknowledge that being a man is very different than being a woman in this career. Women have a whole pile of extra barriers. So all the comments I make in the context of that. But I think in my career, I was just, reflecting on this question that I don't know if I could have done this now, starting out now. I think the whole funding environment and the challenges are so much harder for early career researchers now. And, there are no easy answers, but, I think taking advantage of opportunities, and most opportunities come along, a lot by luck, almost always unanticipated, seeing the opportunities and taking advantage of them. And sometimes there is opportunity in adversity, when something bad happens, for example, like my big grant being turned down, quickly see the opportunity in that. So I think it's being able to see those opportunities and have the confidence. And a lot of people just are inherently unconfident. People talk about imposter syndrome, and I'm like that as well, but just gritting your teeth and taking a big breath and having confidence in yourself to do things a little bit, left field, out of the square. So that's one thing. And then obviously getting funding is a key thing. So that's about just perseverance and not losing confidence in yourself when the grants get turned down.
Or being willing to change direction, right? Which it sounds like you did several times, and having the braves to step into that unknown. It sounds like you have definitely done a couple times, kind of branch off into something new.
Yes, so that's important. And get feedback, attention to detail, and then mentoring. So I had wonderful mentors, and I think that now that I'm more senior, I'm trying to mentor younger people as well. So I think mentoring is critical.
Yeah. And, I think that's really important, kind of this both ways, right? Both mentoring and sponsoring people, recommending people for things is also really important.
Absolutely.
I want to thank you, Tony, for joining us on the show. This has been such a fun discussion. I definitely look forward to the ongoing evolution of this work in gout in the years ahead. And I'm hoping that you will start studying gout in women, because I do think that's very important. So I also want this episode to give a special thanks to all the patients who donate their samples to large biobanks. Often they never learn what happens to their specimens or how their contribution has changed paradigms in science. But their gifts and willingness to be part of large biobanking research studies are essential for helping us understand the genetic underpinnings of disease. Thank you all for listening to this podcast. ACR Journals on Air is a production of the American College of Rheumatology. Please follow @ACRheum on social media and rate and subscribe to our podcast at acrjournalsonair.org or wherever you get your podcasts.